Okay, so how do we get to the two formula? Okay, so first of all, in a plane like this, how do we define angle? It's like a y-axis, x-axis on graph. Okay, this x-axis on the right hand side is 0 degree and move anti-clockwise direction. So this is 90 degree, 180 degree, 270, and come back 360 degree. Okay, so imagine if I have to draw a circle, alright, and I draw a line somewhere here, and I define this as my theta. Okay, and if I form a right angle triangle this way, alright, this will be my opposite, this will be my adjacent, and this is hypotenuse. Alright, so what are these three sides? If since this is on x-axis, I call this value x, and since this is on y-axis, I call this value y. So my opposite will have a value of y, adjacent x, hypotenuse, maybe let's use some other alphabet r. Okay, so what do we have here? Okay, always let's recall dwa, ka, and so. So if I want to have a sine ratio of this angle, so sine theta will be equal to O over H, which is, in this case, opposite is y, H hypotenuse will be R. Okay, so now let's look at another triangle. If I have a mirror image of red line, let's say if this is a mirror image of the green line, and if I call this theta, okay, so similarly, if I draw this line down, since this is a circle and this is the center, these two lines are the same, this is my R, and this value will have the same x value, and this value will have also y value. However, please take note, on the graph this is your actually negative side, so this is actually negative x. Okay, notice that if I have this line here with this angle, I cannot form any right angle triangle. So what to do? Okay, in this form like this, okay, we always take the hypotenuse and the x-axis to form right angle triangle. We always take the hypotenuse, okay, whatever this line is, with the x-axis to form the right angle triangle. So this is my right angle triangle. Alright, so sine this theta, this is an obtuse angle. Okay, sine this sine, okay, the Trigo ratio of this obtuse angle will actually be reflected from this right angle triangle. Alright, so if this is the right angle triangle, this is the theta, it is the same as we are looking at this angle. Okay, and this angle, since just now we said this is a mirror image, it has the same value as the green theta. Alright, so again, with this angle, if this is the angle that we are looking at, this will be adjacent, this will be opposite. Okay, so my opposite will have the value of y, adjacent will now have the value of negative x, and hypotenuse remain as r. Okay, also take note, r is always taken as positive. So in this case, sine theta, what do I have here? Sine is still O over H, and I will still have y over r. Okay, I will still have y over r. And if you look at the relationship, okay, this rate theta is actually equal to 180 degree minus the green theta. Alright, so see, these two are the same, these two have the same value. If I rewrite it, okay, let's do it slowly. The sine green theta and the sine red theta are the same. So if I replace the red theta, with this, meaning I substitute this inside here, Oh no, the green color is gone. Okay, let's erase this. Then I should have the green sine theta equal to so sorry. Laptop too sensitive. So this is actually how we get our formula sine theta equal to sine 180 theta. They are actually the same. Okay, what does that physically mean? Okay, this actually means if I have, let's say I have a straight line is always 100 degree, correct? So if I chop into two, one of these must be acute angle. Let's say I call this theta, and this must be acute. And the other angle, let's say this is 180 degree minus theta, and this will be a obtuse angle. What do we prove just now is sine theta is equal to sine 180 degree minus theta. If I have to give some value, let's say if this is maybe 30 degree, then this one will be 180 minus 30, 150 degree. Alright, so sine 30 degree should be equal to sine 150 degree. Okay, let's look at the calculator and let's see it. Okay, wait, hope you can see this calculator. Let's check. Okay, sine 30 degree equal half, which is 0.5. Alright, let's try now. Sine 150 degree also equal to half. That's why this formula is valid. Sine theta equal to sine 180 degree minus theta. Okay, now let's look at cosine. A bit messy, okay, but let's erase this. Okay, let's erase this. Okay, do the similar thing. If I look at the green color, now if I have cosine theta, so C equal to A over H. Adjacent is X, hypotenuse equal to R. And if I look at the the red color side, the obtuse angle, cosine theta, same thing, A over H, Now my adjacent is, take note, it is negative X because it's on the negative region. It really look like graph. Negative X over hypotenuse is still R. So now can you notice cosine theta, the green color cosine theta and red color cosine theta, actually they have the same value. They have the same value, X over R. However, what is different? There's a minus sign here. Alright, so there it comes. That's why, so if I have to do a similar thing, cosine theta will be equal to, okay, or in another word, how should I phrase it? What is the link between cosine theta, the green and the red cosine theta? Okay, they are opposite to each other, so how do I make them equal? Simply just add a negative. Alright, if I add another negative over here, it will actually become positive X over R. So that's why just now we also proved that these two theta, what is the relationship? They are actually negative of, they are 180 degree, they are supplement angle. Okay, so in other words, if I write it, cosine theta is equal to negative cosine 180 degree minus theta. So okay, just do some arrangement, maybe change the sign over. I will get cosine 180 degree minus theta equal to negative cosine theta. So this is our second formula. So similarly, let's prove some show. Okay, what it means, same thing, straight line 180 degree. Let's use, if you want to use some other value, maybe now let's say this is theta, so this will be 180 degree minus theta. And if I let this be, maybe use some weird value, 40 degree, this one will be 140 degree. So let's press the calculator and see what is that. Cosine 40 degree, cosine 140 degree. Let's see, cosine 40 degree. Okay, it's actually 0.766. 0.766. So now we have to test cosine 140. Can you see? The value is the same but negative. 0.766. So this is what we mean by cosine 180 degree minus theta is actually has the same value as cosine theta but with a this computer are really with a negative. Alright, so this is what we need to learn for Trigo ratio of obtuse angle.